Good afternoon, everyone. I'm Sathwika from CSC department. In this video, I'm going to give a presentation on pandas in Python. Pandas, they are used for data analysis in Python. They are one of the libraries in Python, and they're powerful and productive Python data analysis and management library. So pandas, they work on panel data system and they're open sourced by Acure Capital Management LLC in late 2009. 30,000 lines of tested Python or Python code, and they are basically used in production of many companies. And besides that, as I have stated earlier, they are powerful and productive Python data analysis and management library. And the features of pandas are they are built on NumPy and they give high performance array computing features, and they are flexible data manipulation. They are capable of spreadsheets and relational database. The capabilities including spreadsheets as well as relational databases. And they have another feature called sophisticated indexing functionality, which deals about slicing, performing aggregations, selecting subsets of data. These all are made easy. And another feature states that rich data structure functions, which enables working with data fast, easy, and expressive. And pandas, they are built on top of NumPy with its high performance array computing features, and they have got flexible data manipulation capabilities of spreadsheets and relational databases. The sophisticated indexing functionality are used to perform slice, dice, and in order to perform segregations, select the subsets of data, etc. And they enable rich data structures and functions to make working with structured data fast and easy and very efficient. And the ideal tool for data scientists, these pandas are basically an ideal tool for data scientists, and they are used for munging the data, cleaning the data, and analyzing the data, modeling the data, and organizing the results of the analysis into a form suitable for plotting or tabular display. Now, working with pandas. First of all, how to install pandas. So installing pandas is very similar to that of installing NumPy. To install pandas from command line, just we need to type in pip install pandas. And to work with pandas library, we have to import pandas as PD. So pandas purpose and overview. Python library to provide data analysis features. It's similar to R, MATLAB, and SAS, and it is built on NumPy, SciPy, and to some extent, it has some features of Matplotlib. And the key components provided by Pandas include series and data frame. So, coming to Pandas data structures, what we're going to learn about is series and data frames. So a series, it can be seen as a one-dimensional array with some index values, whereas a data frame, it is a two-dimensional data structures having rows and columns. So this is an example for series, whereas this is an example for data frame. It has got only one dimension. On the other hand, it has got two dimensions. Now, series is an one-dimensional array-like object, and it contains an array of data of any numpy of data type. Like it has some associated array of data labels like the index, and default index, it ranges from 0 to n minus I. So for values, we're going to represent it as s dot values, and for index, it is represented as s dot index. And this is the notation for series. So one-dimensional array-like object containing data and labels or index is termed as series in Panda. And there are lots of ways to build a series. So let's try to implement this. First of all, you have to import pandas as PD. And then let's say S stands for series, PD dot series of list of label A, B, C, D, E, F, and let's print S. So we have obtained a data type of object, and we are obtaining the indexes as 0, 1, 2, 3, 4, 5, and their corresponding values as A, B, C, D, E, F. So now creating a series. A series can be created from scalar values, dictionaries, and NumPy arrays. And for this, we have to import pandas as PD, where we are giving an alias name to pandas, and series is equal to pd.series, and we are importing some list. Then we have to print the series. As we have seen here, it's the same. So instead of list, they have given the labels called 10, 10, 20, 30. Let's say 10, 20, and 30. Let's try to run. So we have obtained, for 0 index, we have obtained a corresponding value of 10. For 1, we've got 20, and for 2, we have got 30. And the data type is int of 64 bytes. So these are indices, and these are the corresponding values. This is a list. We are giving an alias name to pandas. This is a series object, and this is the data type value. Now, accessing this series. We can access series elements through positional index or a label index. Here we are importing pandas as PD, and we are trying to access this positional index value that is string at some index of 2. So we'll get indexing starts from 0, 0, 1, and 2. We'll get the output as 40. Let's try to implement this program. S is equal to print S of 2, 15, 20, and 40. So let's try to run this program. So we get the value as 40. If we try to access the value at index 1, we'd get 20, and at 0, we'd get 15. So now, okay. Now we're done with positional index. Let's try to access the label index as well. Let's say start tabs is equal to pd dot series. Of New Delhi and Washington, DC. And let's say London. Now it's Paris. And then index is equal to India, USA, UK, and France. We have to print string caps of India. we've got New Delhi as an output. Since for at the value at index of India, we have got the value New Delhi. So New Delhi will be displayed onto the output screen. If we apply string caps of at the index of USA, so we'll get Washington DC, and at UK, at index UK, the value would be London, and at France, at an index France, it would be Paris. Okay. So heading back to the presentation slide. So we can also use negative indexing and slicing in order to access series elements. For this, we have to import pandas as PD, then string caps is equals to pd.series, and we're importing certain values with their indexes. And we have to try to print the index for negative indexing, we have to assign some negative numbers. And for slicing, we have to use a colon operator in between, and we have to assign each digit to the left and right. And let's try to implement this program as well. We have to print string caps, then index same -1, and later we have to print string caps at 1 and 3 using slicing operator. And so let's try to run this program now. So we've got the values. First, at string caps of -1, we'd get Paris. I mean, at index -1, Paris is present. And then from 1 is to 3, we'd get USA. So this is the index 1. And later, the value present over here is Washington, DC. And at index, it's 2, UK. The value present is London. So using slicing operation, we'd get the indexes, the respective indices with the corresponding values. And the D type object here is data type value is here is object. And okay, now working with index. So a series index can be specified, and a single value can be selected by the indices, and the multiple values can be selected with multiple indices. And so let's try to implement this program. So Pandas as PD, where let's say S is equal to F, A, C, and E. Sorry, this is the index. And before that, S is equal to PD dot series of 2, 4, 6, and 8. Next, we have to print S. Shall run this. Okay. So now we'd get the value at index F as 2, at index A as 4, at index C as 6, and at index E as 8. And the data type is integer of 64 bytes. Now for single value, it can be selected by a single index, but for multiple values, it has to be selected with multiple indices. And we're done with the single value. Now let's try to implement the other two values as well using the multiple indices. Now if we want to print S of A, then we have to print S of A and C. So at S string of A, I mean we have obtained the value 4, but at A and C, at indices A and C, we have obtained 4 and 6, which is of integer data type again. Since the value 4 is present at index A, so we have obtained 4 as an output for single index A, and at A and C, the values 4 and 6 are present. So we have obtained multiple indices for the so we have obtained multiple values for the multiple indices. Now we have to think of a series as a fixed length and an ordered dictionary. But however, unlike a dictionary, index items that don't have to be unique. So let's try to implement this program. Let's say S2 is equal to PD dot series of range 4, and let's index is equal to list of AB and AB. Later we have to print S2. Let's run this program. So we have obtained 0 at index A, 1 at index B, 2 at index A, and 3 at index B respectively. Now let's try to print and later let's try to print S2. From this cell. So at S2 of A, we have obtained two values. A at index A, it has got two values, that is, it has got 0 and it has also got 2. And at A of 0, at index A, it has got only 1 0 as its value, since we have specified over here the value of 0 is at A. And if we want to access the value So it's invalid index to scalar variable. I mean, we can access only a single value at a time. Okay. So it index to its out of bounds for access 0 with size 2. So here we have to give the size 0. Okay. So now 0 and 2 both share a common index, that is A. So it's displayed onto the output screen. So here index items, they don't have to be unique. They can take two values at a time. So series functions, some useful series functions or methods are head, tail, and count. Head method, it returns the first n numbers of the series and the default value is 5. Tail method, it returns the last n members of the series where the default value is 5. And the count method, it returns the total number of non-NaN members of this series. NaN stands for null. Now, some operations done on series are filtering and NumPy type operations on the data. So let's try to implement this program. Let's import NumPy as np and s is equal to pd dot series of 2, 4, 6, and 8. Let's print this. Before that, the index values are F, A, C, and E. So we'll be getting the values at the corresponding indices. And now let's try to print S if S is greater than 4. So now we have obtained values. The values where S is greater than 4 are 6 and 8, having indices C and E respectively. And if S is greater than 4, so it's F, A, C, E. Here 2 is not greater than 4, so it returns false. And 4 is not greater than 4, it returns false. 6 is greater than 4, it returns true. And 8 is greater than 4, it returns true. This is of data type Boolean. And if whether S times 2, I mean, this is a multiplication operation. So what if 2 times of 2 gives 4, 4 times of 4 gives 16, 6 times of 6, I mean, 4 times of 2 gives 8, and 6 times of 2 gives 12, and 8 times of 2 gives 16. So this is of data type integer. Coming to incomplete data, pandas can accommodate incomplete data. So let's raise a program node to support this statement. Let's print S. Let's run the program. So we have obtained 100, 150, 200 as values at corresponding indices B, C, and D. And here if we take pd.series of S data, list of A, B, C, D. So we'll get a null value at A since A has got no value. And let's try to print the values are double here. And now automatic alignment. Unlike in a NumPy ND array, data is automatically aligned. And let's support this statement. String 2 and pd.series. Let's take a list of values which has got some index. Have to print S2. Okay, so we have obtained 1 to 3 as values at corresponding indices C, B, and A of data type integer. And if we just print take S as PD dot series of S data, and the data is C of 150, then D of 200. Have got the values B, C, D. Now let's try to print S into S2. So here, since A, B, C, A and D have taken null values and B, C have got 200 and 150. So in the first series, there's no A value, but we have got 3 as A, and A takes the value of 3. And if say for S data, we have got D value as 200, but in the second series, there's no D value. So D value is assigned as NaN, that is none of the null value. Here 100 is multiplied with this B value present in second series, that's 2, and C is multiplied with the C value, that's 1. So since multiplication with a null value, it gives a null value. And now, so here we have performing few operations like mean, and let's try to do this. And first of all, we have to import pandas. No, let's import numpy now, where random number is assigned as numpy dot random dot from pandas. We have to import asterisk, and S is equal to some series of random value 3 and A, B, and C. Now let's print S. We shall run this program. So we would get the value. And if we the mean is minus 0.16133, and this ABC has taken some random values, some 3 random values. Now heading back over here. So series 2 from dictionary using the dict keyword. So series to Python dict, no more explicit order needed, but back to a series with a new index from sorted dictionary keys. So let's try to implement this program too. numpy dot random from pandas import s is equal to and we have to print dict of s, then later print series of dict of s. So let's try to run the program. So these are the corresponding values are obtained onto the output screen. And we have got some random values over here. Let's head back to the presentation slide. Now, reindexing labels. So let's implement this program as well. We shall print s dot index and s dot reindex. We shall run the program now. So we have got the values. Now let's head back to the presentation slide. So the vectorizations here series work with numpy as numpy dot exponential of s. So let's try to implement these two programs as well. Print s plus s. Then we have to print numpy dot exponent of s. Then we shall run this program now. So we have obtained some random values onto the output screen. So now heading to Pandas data frame. Pandas data structures, they're spreadsheet-like data structures containing an ordered collection of columns, and they has both a row and a column index, and it is considered as dict of series with shared index. So now like data.frame in the status, it's same like data.frame in the statistical language or package of R. And it is a two-dimensional tabular data structure, and it is used for data manipulation with integrated indexing. And it supports heterogeneous columns, and it also supports homogeneous columns as well. So here Pandas data frame, the key features are heterogeneous data, size mutable and data mutable. And the size and data both can be modified. And a Pandas data frame is a two-dimensional array. It is a data aligned in rows and columns. The general format is pandas.data frame, data index in columns and d type. Here data, it is like ND array, series, list, dict, constants, or another data frame. And index, it is used for row label. By default, index ranges from 0 to n minus 1 as np dot arrange of n. And here columns, it is used for column label. By default, it ranges from 0 to n minus 1 same as np.range, and the d type is nothing but a data type of each column. Now we are going to deal with this entire topics, like starting from creation from a dictionary of series, list of dictionaries, text or CSV files, display, iteration, and operations on rows and columns, how to add, select, delete, rename, head and tail functions, indexing using labels, Boolean indexing, importing or exporting data between CSV files and data frames. We're going to focus on all these topics now. First of all, creating data frames. So data frames can be created from any of the basic data structures like lists, dictionaries, dictionaries of lists, array lists of dictionaries, and also from series. And here, an empty data frame can be created as follows by using this particular program. We could actually display the output onto the screen in order to create an empty data frame. So now let's try to import pandas as PD, and here frame emt is equal to pd dot data frame. Have to print d frame emt. So here we have printed empty data frame of columns and indexes as empty onto the output screen. Let's head back to the presentation slide. Now, how to create a data frame using list. So for this, capital D is equal to pd dot data frame ten, 20, and 30, 40. So let's try to print D. Now shall run the program. So these are 0 and 1 are default columns, and here 0 is termed as the default rows. So we have got the same output as displayed on the screen. So this is a column 1, column 2, column 0, column 1, column 2, column 3, and column 4. And here is the axis 0, and it has got axis 1. In rows case, this is axis 0, and this is axis 1. So it is row 0, row 1, and row 2. Now, how to create dict of equal length list using the data frame. So let's consider the data. Say state the year is 2010, 2011, 2008, 2010, 18.8, 19.1. Later it's 9.7, 9.7 again, and 9.8. And here frame is equal to pd dot data frame of data. We have to print frame. So we'd get a dict of equal length lists onto the output screen. Now let's try to create data frame from a list of dictionary. Data is equal to let's run this program. We've got the value onto the output screen and have created a data frame from a list of dictionary. Now let's head back to the presentation slide. So how to create data frame using dictionary? Now we are importing data as name of Anu. It's Sia, and marks as 1925. Then later capital D is equal to PD dot data frame of data and index. Let's print D. So here we have obtained marks and with corresponding name. Anu has got 19 marks and Sia has got 25 marks. And the column names are the keys in a dictionary, and the rows we have used index for the rows. And so now let's try to create data frame from a dictionary of series. D is equal to 1 PD dot series 10, 20, 30, and 40. Index values are A, B, C, and D. To PD dot series, that's 10, 20, 30, and 40. Corresponding index is A, B, C, and D. You have to print So here we have obtained series of values onto the output screen. Let's try to run this program. So let's head back to the presentation slide. And now let's try to implement this program as well. This is of a result sheet. Equal to Arnab PD dot series 90, 91, and 97. Maths, science, and Hindi. Grammar PD dot series 92, 81, and 96. Then index is equal to maths, science, and Hindi, now it's Samriddhi, PD dot series of 89, 91 and 88. The index is maths and it's science. Hindi again. It's Priya. PD dot series 81, 71 and 67. The index is maths, science, and Hindi. Now it's Malika and the PD dot series values are 94, 95 and 99. Maths, science and Hindi. Now result PF is equal to PD dot data frame result sheet. Then we have to print result DF. Let's try to run this program. Here we have obtained data frame from a dictionary of series. Let's head back to the presentation slide. Now creation of a data frame with dict. So let's try to implement this program as well. Underscore data. Twenty 18.8, 2011, 19.1, and then GA 2000A, it is 9.7. 2010, it is 9.7. And for 2011, it is 9.8. Now let's try to print the pop value of pd dot data frame try to run this program now. So we have obtained the values onto the output screen. Let's head back to the program now. Okay. Now how to select column. We can select a column using dot notation or using square brackets. And if there's a name called Anusia Jia and M1, M2, the mid marks of M1 and M2 and the total. And if we want to print the total marks of M1 and M2 with print name, so we can use this dot notation in order to obtain the marks. Let's try to print this program. Starting, we have to import pandas as PD, and then we have to give a data that is name as Anu, Sia, and their M1 marks as 19 and 25. And also, let's try to print another name called Gia. M1 marks as 19, 25, and 23. And M2 marks as 13, 24, and 13, 34, and 24. Then later on, we can display total. Let's say that D is equal to PD dot data frame of data at index 0, 1, and 2. And then D of total is equal to D of M1 plus D of M2. And now we have to print D. So this is the output. Now let's try to have a look around here. Further, let's try to print D of total and print D of M1 and M2. Then we shall print D dot name. Let's try to run this program. So we have obtained the output onto the screen. Let's head back to the screen. So here total in the sense the average of M1 and M2 gives us 32, 59, and 47. And dictionary of M1 and M2 in the sense, the marks of M1 and M2, that's 19, 25, 23, and 13, 34, and 24. And name is it's Anu, Sia, and Jia. And here D type is object. Now here we want to add column and insert column. So how could we do that? We shall see with a program. So for time being, let's have two values. Let's delete this entire thing. And here we shall print D, and then we shall print D of M2 is equal to 13 and 34. Now here D of total is D of M1 plus D of M2. Now we shall print added columns. D, which is separated by skip sequence. And then we have to print inserted columns. Then here D dot insert. One, that is the remarks. A and B. Later we have to print D. Shall run this program. So we have obtained the output onto the screen. Set back to the slide. So now this particular index, data and the index, which has the corresponding index, it indicates that here name is considered as a key, and this is corresponding index. The rows have the corresponding index as 1 and 2, and here name and M1 are considered as keys in the dictionary. And then we are adding the columns, that is M1, M2, and total. And then we have inserted columns called remark over here. So we can use the dot notation to insert column or add a column. Now, if you want to add a third column, we could simply write df at 3 is equal to s times of 3, and this will share the existing index. Now, if we want to access to columns, we can access by attribute that is df.1, or else we can access by dict-like notation of tf of 1. Both gives the same output. Now let's head back to the presentation slide. So this, and here columns, they can be retrieved as a series with dict notation and attribute notation. And here rows can be retrieved by using position or by name using ix attribute. Here frame of state is FL, FLG, and GA, and the name is state. So here we have we are using frame dot describe in order to describe the bound method. So let's try to implement this program. Here we are using a data called state. Year 2010, 2008, and 2010, 2011 as well. And then 18.8 is 19.1. This is 9.7. And even this is also 9.7. It's 9.8. And here frame is equal to shall print the frame. And then later print frame of state. We shall print frame dot describe. So this is the output. And here new columns can be added by computation or direct assignment. And let's try to implement this as well. your frame of other then we shall print frame and frame now we shall print this frame and let's run the program. We have obtained this onto the output screen. Now let's head back to the presentation slide. Okay. Now how to create a data frame with row index and column label. So let's try to implement that. First, we have to import pandas as PD. Later, data is equal to 1020 and 3040. Capital D is equal to PD dot data frame, which is equal to column 1 the index is equal to row 1 and row 2. Now we have to print B. Let's run this program. So now we've obtained this is a column label and this is a row label. Let's head back to the slide. So how to iterate in a data frame and how iteration is done. Let's try to implement that. First, we have to import pandas as PD, and then the data is equal to 1006, 1008, where A1 and the B1 23,000 and 19,000. Capital D is equal to PD dot data frame of the data. We have to print D, and later we have to print D dot shape and the D dot size for row. In range of D dot shape we have to print row and then columns, and then for column in the range of D dot shape of 1, we have to print and row where n is equal to, now we have to print this program. Let's run the program. So we have obtained the output onto the screen in this manner. And let's head back to the slide. So how to iterate the data frame using the iter rows keyword. Let's try to implement this program as well. Now we should import the pandas as PD, and the data is equal to name, Amy, Anu, Jia, and the total is 45, 32, and 76. The capital D stands for PD dot data frame of data. We shall print D, and for I in D dot iter rows, shall print I. Okay. So now let's try to run this program. So we have obtained the name Ami, Anu, and Gia at indices 0, 1, 2 respectively, and the total is 45, 32, and 76. So in this way, we can perform the iteration in data frame using iter rows. And iter rows, it is used for iterating over the rows as index has series pair. So now how to add row at the end. So let's try to implement this program as well. Now here what we're doing is have to import pandas as PD, and then data is name, that is Anu, and it's Sia, where the M1 marks are 19, 25, and M2 marks are 13 and 24, and 34. Next, total is 32 and 59. And here D is equal to PD dot data frame of data at an index 1 and 2. Now we shall print D, and D dot location of 3. GR 23 and 24, 47. Print added row using separated by escape sequence. So now this is the output, the desired output that we have obtained onto the output screen. And now let's try to append using D dot append. Name, Sumi, and M1 marks are 21. So M2 marks are 19. And the total is 40. And then now we have to ignore. Here we have to ignore underscore index is equal to true. And then later we have to add print added row using append mode, then D, and it is separated by the skip sequence. So let's try to run the program now. So now let's try to implement the program. Here D is equal to PD dot data frame of the data which is present respective index 1 and 2. D dot let's try to run this program. So this is the required output that here rows are added at the end. The desired output has been displayed onto the output screen. And now let's try to implement another program. It states how to delete a column and a row. So to delete a single column, we use del pop drop, and to delete multiple columns, we use drop. To delete single or multiple rows, we use drop. So let's try to implement this program. And now first of all, import pandas as PD, and then data is given as name. Anusia, and it's Gia. And the M1 marks are 19, 25, and 23. Next, coming to M2 marks, they are 13, 34, and 24. And D is equal to PD dot data frame, data and index at 0, 1, and 2. Now we have to print D. Before that, let's add its total, which is equal to D. This is D dot M1 and plus D dot M2. Next, we have to print the added columns, where we have to print the D, and this is, we have in the dictionary. So let's try to run the program. Now further, we have to delete columns, and columns is equal to its name, and in place, if it's true, let's say we have to print D, then later D drop columns M1 and M2, in place of true, have to print the dictionary, and further D drop index at 0 and 1, in place true, have to print the dictionary, which is D, and let's say so let's try to try to run the selected program now. So these are the desired outputs. These are the desired outputs, and Now let's try to rename the column using So now let's try to rename the column using d.rename as a keyword. And this particular, it changes the column name. And by using this particular column, it changes the row index name. Let's try to execute this program now. So we have to rename using the rename keyword of columns as name, that is student name, and in place it's true. We shall print the now it's d.rename of index 0 and 1. Columns equal to total in place is true. Now we shall print the so let's try to run this program now. All right. Now, so let's try to rename the column label or row index. Now we have to print d.columns. So we shall print here d.columns and have to print d.index. Then we shall print this d.columns equals A and it's B and then it's D, I mean C and then D. Then later we have to print this d.index of 1, 2, and 3. This is the desired output. And so how to perform head and tail operation. Head in the sense it inserts, I mean by default its value is 5, so it displays it displays the top 5 rows, and tail in the sense it displays bottom 5 rows. So let's try to implement the program using head and tail operation. And let's print this program. Top 2 rows, that is d dot head 2, and which is separated by an escape sequence, and have to print bottom 2 rows, which is p dot tail of 2. It has to be separated by n. We print this. So this is the required output. So head method, it displays the first 5 rows, whereas tail method displays the bottom 5 rows. Now accessing and indexing data frames. As data elements in a data frame can be accessed using indexing, and there are 2 ways of indexing data frames. They are label-based indexing and Boolean indexing. So there are 3 ways of indexing: data frame of column 1, and column 2 for column operation. And this particularly is used for labels, slicing operation, and for position, the default index, we use df.i location. So for the same program, we're going to perform the operation. Have to print select name column, which is separated by an escape sequence. Then we shall print select row and column. d.ilog, and even this is also separated by next we have to print select second row, d.ilog, separated by skip sequence. And let's try to run the program. So this is the desired output, and so next going to the concept of indexing using the label or position. So now let's try to implement this program as well. Here we shall print D of total and we have to print D dot ilog at 1 and 2, at 0 and 1. Then we have to print D dot ilog at 1 and 2 of name, which is M1. Then we have to print D dot ilog at 0, 3, 2, and then later we have to print D dot location at 0, 3, 2, and this user name. Total two, and let's try to run this program now. So we have obtained the desired output onto the screen. Now let's try to print the dictionary values of D dot M1, whether it's greater than 20, and D dot M2 is greater than 20 again. Next, we have to print D dot M1 is greater than 20 and or operator D dot M2 is greater than 20. Now we have to print D E dot total is greater than 40. Now let's try to run this program. So this is the output. And now Here let's insert another row which says print d dot total, for example, is greater than 50. So let's try to run this program now. All right. So now let's head back to the presentation slide. So we have done with all these programs. Now let's try to understand the concept of label-based indexing. For example, we'd like to print the marks of science for all the students. So for this case, let's try to import pandas as PD and result sheet is equal to Arnav PD.series of 1991 and 97, and the index is math, science, and also Hindi. Then Ramit PD.series of 92 and 81 and then 96, and the index is that of maths, science, and Hindi. So summary, it's PD dot series of 89, 91, and 88. Index of maths, science, and Ria, it's PD dot series of 81, 71, and 67, which is having an index math, science, and Hindi. And Malika, PD dot series of 94, 95, and 99, which is having an index of maths, science, and Hindi. Now, result TF is equal to PD dot data frame of result sheet. Now we have to print the result TF. Let's try to run the code. All right, now let's try to find the location of science and then later let's try to find the location of Ria. Now let's try to find the location of math and Hindi. Now let's head back to the presentation slide. We have implemented this. Now, coming to Boolean indexing, to display whether a student has scored more than 19 science, so we would try to implement this program. For the example, option of science greater than 19. Let's try to run the program as well. So yeah, so this is another example which states the functionality of Boolean indexing. This is an example program of Boolean indexing. Try to implement this program now. Pop underscore data FL of 2010, 18.8, and 2011, 19.1, and this is GA of 2008, 9.7, and 2010 of 9.7. Then it's later 2011 of 9.8. Now pop is equal to pd dot data frame pop underscore data. Now we have to print pop. Then we have to perform these operations. Print pop less than 9.8. Then print pop of pop less than 9.8. This is the desired output. And now slicing the data frame. So to display the rows of math till science, let's try to see this example as well. Location of math and sciences. So this is it. And now how to append to data frame and sort. First, let's import pandas as PD, and then later on data is equal to name of A and B, and then total equal to 89 and 78. Here capital D is equal to PD dot data frame of the data. Now we have to print D. Then data 1 is equal to name of C and D. Total 78 and 91. D1 PD dot data frame of data 1. Next, to print D1, then D2 is equal to D dot append of and of D1. Now we have to print D2, and later on we have to print D2 dot sort underscore values of total ascending equals false. Let's try to run the program now. So now let's head back to the presentation slide. And now how to perform re-indexing functionality in order to create new object with the data conformed to a new index. We can actually implement this re-indexing operation by a sample program which is displayed on the screen. And let's try to do this. Import pandas as PD, where object is equal to PD dot series of blue, purple, and spread. And later index is equal to 0, 2, and 4. Now we have to print the object. Then we have to print object dot reindex at the range of 4. Further, we have to print object dot reindex the range of 5. Fill underscore value is equal to black. And then later we have to print object underscore reindex, then a range of 5, and the method is a fill method, and let's try to run this program now. So this is the output. Let's head back to the program. Now, if we want to reindex CB and A, we can do this by df.reindex keyword. And we would get the desired output to the screen. Now, in order to drop entries from an axis, we can use this df.drop keyword, and the element which we want to drop the entry from the axis, we should insert the element over here. And if we want to drop entries from an axis of more than one element, so we can drop in df.drop of B and A using a list. So coming to descriptive statistics. So the main utility of Pandas data frames is data analysis. And descriptive statistics means applying some functions in order to analyze the data. So descriptive statistics, it not only includes mean, but it also includes count, sum, median, minimum, maximum, abstract, and product as STD values, variance, skew, curd, quantile, cum-sum, cum-prod, cum-max, and cum-min. And So in order to summarize and descriptive statistics, so do we would try to implement this program. Now let's print pop dot sum, and let's print pop dot mean, and print pop dot describe. Let's run this program. So yeah, this is the desired output. So calculating max and minimum function. So print df.max, it will print maximum value in each column, and print df.max of axis equal to 1, it prints the maximum value of axis in each column. And this particular statement, it will print the maximum value for ut2. And so this is a program. So in order to calculate sum, mean, median, and mode, can print df.sum, where df of maths.sum and df Raman of maths science, and this s.st Hindi and English.sum, and we can actually print df.count in this manner. So we use this keyword df.count using dot notation in order to perform the descriptive statistics. So by default, all these functions are applied to rows of axis 0, and for columns axis is 1, it is mandatory. And there's a note that d dot max, it can be written as d dot max of 0, and d dot count of axis equals to 1. It can be written as d dot count. So let's try to implement this program as well. and M2 is 13, 34, and 24, right? So now let's try to run selected cell. Let's nineteen and let's take M2. Here M2 is 13 and 34. Okay. So now let's E dot location of 0 and 1 and 2 is it, and it's 23 and 24. So now try to run the cell. So yeah, now here we have obtained the desired output. And now let's try to perform few operations. Let's print d dot max and let's print d dot count of axis is equal to 1, and let's print d of total dot min, and let's try to print d of m1 and m2 dot sum. Let's try to print d of m1 and m2, then the total dot mean. So let's try to run this. So we have obtained the output onto the screen. Now let's head back to the slide. So computational tools are covariance, where S1 is a series of random number of 1000, S2 series of random number of 1000, and S1 dot covariance of S2 gives us the output in this manner. So let's try to generate, import pandas as PD, where S1 is equal to series of random number n of 1000, and S2 is equal to series of random number. Now S1 S3 is equals to S1 dot covariance of S2. So now I have to print S3. Let's run this. So it's minus 0.0196, a random number has been generated onto the screen. And now let's have a look at data loading. A Pandas supports several ways to handle data loading. That is text file data to read CSV and to read table. Structured data just on XML and HTML. It works well with existing libraries, and Excel, it depends upon XLRD and OpenPyXL packages. With the database pandas.io.sql module read underscore frame. Now in order to plot the data, so this is a bill, and so we can plot the data by using bar graph and also by using histograph and by histogram, also by bar graph. This can be done using the matplotlib library. So far we have seen about how to group by split, apply, combine, and merge, join, and aggregate. So, and We didn't see this plotting with matplotlib and the time series or data or date functionality, reshaping and pivot tables, IO tools like text CSV and HDF5. So we shall see these topics in this upcoming slides. So data aggregation can be done by group and pivot tables and the time series like periods of frequencies, operations with time series with different frequencies, downsampling and upsampling, plotting with time series, auto-adjust scale, advanced analysis like signal frontier analysis, future contract rolling and rolling correlation and linear regression, decile and quartile analysis. So these all can be offered by Pandas. So just we try to cover time series and this date functionality, the CSV files in this upcoming slides. So writing data to CSV file, so we have to import Pandas as PD. Then we have to write the data which we would like to import to a CSV file. Then we have to import this data and index. So d.to underscore CSV file. And this format, we are writing some data frame data to an Excel file. So now how to create data frame using text or CSV file. So we have to import pandas as PD and then the data which we want to create. I mean, the data which we want to, like the text which we would like to enroll, I mean, which we would like to insert in the CSV file. We can do that and you can create the CSV file using .csv file extension, which can be attained by using Notepad or Excel. And we can read the data in Excel file to the data frame by using this command. So this would be displayed in this format. Now in data frame, axis equal to 1, it represents the column elements. And in the pandas, the function used to check for null values in a data frame is null. So if we consider this following data frame, so in order to write down the command that will give the output is print df.max. Here, we would like to find out the maximum value. So we would print df.max. So if the teacher needs to know the marks scored by the student with roll number 4, and we have to help her to identify the correct set of statements from the given options. So option A and option D satisfies, I mean, the given statement. If the teacher wants to know the student with rule number 4, then we should access the rule number 4 and we have to print this particular data frame D1. And both option A and option D satisfies the given statement in this regard. So next, if Miss Sharma is the class teacher wants to add a new column, the scores of grade with the values A, B, A, B, A to the data frame. So we have to help her to choose the command to do so. So for this, option B satisfies. So if data frame of the grade is equal to AB and BA, so the location, it does not satisfy the value, I mean, it doesn't satisfy, and df.column also, it doesn't satisfy the given statement. Now, which of the following statements will give the exact number of values in each column of the data frame? So print df.count, it gives the exact number of values in each column of the data frame. And also the print of df.count of 0, it also gives the exact number of values in each column of the data frame. And so which of the following command will display the column label? It is print of df.columns. Now, if we consider the following data frame or class frame, this is the roll number of the student 1 to 4, and the names of the students are given as Aman, Preeti, Kartika, and Lakshay. They belong to class 9, 10th, and 9th, 10th, and the section is EFDA. The CGPA system is 8.7, 8.9, 9.2, and 9.4. And the stream they have opted is science, arts, science, and commerce. So we have to write commands to add a new column activity to the data frame, and we have to add a new row with values like 5, Mridula, XF, 9.8, and science. So we could add a class frame with activity as a value, and we would add some new values like say random ABCD. And for class frame of location student 5, we would add this 5 Mridula, X, F, 9.8, and science. X, this is 10th female, 9.8, and science. I mean, this F section, 10th F, we would like to access this using the location of the student 5, that is roll number 5. The name is Mridula, class is 10, section is F, and the CGPA system is 9.8, and the stream here is science. So now we have to write a program in Python, Pandas, to create the following data frame batsman from a dictionary. And we should perform the following operations on the data frame, like we should add both the scores of a batsman and assign to column total, and we should display the highest score in both score 1 and score 2 of the data frame. We should display the data frame. So we could import pandas as PD, and then data is b underscore number of 1, 2, 3, 4. Then we import name as Sunil Pillai, Gaurav Sharma, Piyush Goyal, and Karthik Thakur. The scores would be 90, 65, 70, and 80. Then score 2 would be 80, 45, 90, and 76. Then here batsman is equal to pd dot data frame of the data. Then we would print the batsman's total, the sum of score 1 and score 2 of the batsmen, and the batsman score would be the maximum of the scores 1 and 2. And we should print, finally we should print the batsman name onto the screen. So let's try to implement this program. First we have to import, let's import pandas as PD. And then data is equal to b underscore number of 1, 2, 3, and 4. And the name is says Sunil Pillai and Gaurav Sharma. Then it's Piyush Goyal and Karthik Thakur. Even score 1, 90, 65, then 70 and 80. Then score 2, it's 80. Eighty, 45, 90, and let's say 76. Now let's try to batsman. Then batsman is equal to PD dot data frame of data. Batsman of total is equal to batsman of score 1 plus batsman of score 2. Have to print batsman of score 1 and score 2 dot max. Later we have to print batsman. Let's try to run this program. So this is the output. Let's head back to the presentation slide. So now we have to consider the data frame DF and write the output of the following. Now print DF of English dot minimum. Minimum in the data frame of English is 75 and DF of English and science dot count. English is 3 and the science English has got 3 scores and science has got 2 scores, and location of 2018 it's and the max of it is English 99 and science just the 99 score. The location at 2018 score is 99 and location of 2018 slicing operation 2019 and the maths and science. So location from 2018 and to 2019. The score of maths and science, it's maths is 99. The max value of maths is 99 and the max value of science is 95. So the drop method in Pandas can be used to delete rows or columns, and the code to display the last 3 rows of the data frame DF is df.tail of 3. Now we have to consider a data frame DF. So this E code is 123 and E name is Sarika, Monica and Mehak. So write the command to add a new column named salary from the list sal of 15,000, 18,000 and 16,000. So this is the list. I mean, this is a code, salary and the names. So we have to insert a salary one using sal keyword, or else we have to insert location one column salary or the value of sal, so that a column called salary gets inserted in between using insert df.insert keyword. So now we have to write a Python code to create a data frame from the list given below. This is the list, and we should give the column heading as empty code, EMP name, and EMP salary. We should also give the index as 1, 2, and 3. So let's try to implement this program. First and foremost, let's import pandas as PD, and then the data. Open. $35K, and this time it's Jatin. 43,000. Deepak, 38,000. Df is equal to PD dot data frame of data and this columns. Empty salary at an index. One, two, three. And we shall print this data frame. Let's run the program. So this is the output. So we have to consider the following data frame and answer the questions given below. So this is the data frame. We have put pandas as PD. And so we have to write the code to find the mean value row wise and column wise. So we can do this by print df dot mean of axis equals to 1 and print df dot mean of axis is 0. And to find the to write the code to find the sum value row wise, we can do this by print df dot sum axis equals 1. So first we have to import pandas as PD. Let's define the data frame as 66, 78, 67, and 98, and 65. Two, 76, 56, and then 69. Then coming to subject 3, that's 65, 64, 74, 72, and 81. And coming to subject 4, it's 90, 87, 56, and 66, and 86. So we can print df dot mean of axis equal to 1. And we have to print df dot mean of this mean of axis equals 0. The first one is to print row wise, and the second one is to print the mean long column wise. Then we have to print df dot sum of axis equals 1. Now let's run the program. So this is the output. Now it's given a data frame df of marks obtained by 100 students as shown below. And we should write a command to compute sum of every column of the data frame. We could do this by df.sum method. And to compute mean of average column, we'd do this by df of average.mean. And the command to compute average of highest and lowest columns, we'd do this by df of highest lowest dot mean. Now we have to find the output of the following code. So first we have to print df1, that is the first data and then index and the columns considering first and second, and it has got ABC values. So let's import this. First, let's import pandas as PD. And then the data is equal to A value, that is 10, and B value is 20. Your A value is 6. And then B1 value is 32. Therefore, C value is 22. TF1 is equal to PD dot data frame of data at index first, second, and the columns A, B, and C. TF2 is equal to PD dot data frame of data at index first, second, columns equals A and B. Now we should print data frame 1 and data frame 2. So let's run the selected cell. So the values have been displayed to the screen. So here we have to write a code in Pandas to create the following data frames. And this is of mark sheets. So let's do that. We have to import Pandas as PD. And later it's TF1 is equal to PD dot data frame of marks 1, that is of 49, 35, 41, and 45. And marks 2 is of 39, 26, 43, and 35. And df2 is equal to PD dot data frame of mark 1, 43, 42, 39, and 40. Then mark 2, gives us 30, 46, 33, and 29. We have to print df1 and we have to print df2. Then later we have to perform some operations. Print df1 dot add of df2. Then later we have to print df1 dot subtract of df2, and we have to print df1 dot rename columns equals mark 1 is m1 in place equals true, and df1 dot rename of index is equal to 0, 1, and in place is true. Now let's try to implement this program. So these are the marked lists. So this we have to consider this following data frame and the command to add a new row to data frame with the values in data. That is data is equal to name Manan, marks 19 and grade C. And the command to change the label of the column label marks to score, and the command to arrange the data frame in descending order of marks, and the output command. That would be, let's implement this program as well. First of all, we have to import pandas as PD. And then later on, should import the data called name. That is Manan. And marks 19. Then grade C. Let's Amit. Marks 10. Grade C. Amit, Ravit, Ria, and Arnav. Then marks with 10, 23, 21, and 11. Then grade would be C, A, A, and C again. And then let's try to insert other student. Df dot location at 4. The name of the student, Manan, 19, and C. And let's try to print Df, and let's run the program. Okay. So now let's perform few operations. It's df dot append data, and we have to ignore index equals true, and df dot rename marks score axis equals 1, df dot sort underscore values marks ascending order, ascending equals false, and later df df of grade and df of marks greater than or equal to 20. Let's try to run this cell. So here name and marks have been displayed onto the output screen. Now we should write the command to display the top 3 rows from the data frame that could be achieved by head method. And to display all the rows, we could display it and the output of the following. So we should import pandas as PD. Then df underscore sales would be PD dot data frame. That's 20, 40, 15, 44, and 10. Eight, 25, 54, 30, 29. 20, 16, 70, 36, 82. Twenty, 16, 70, 36 and 82. Fourteen, 37, 17, 20, and 60. Now let's run. So these are the location at QTR3 and QTR4 at 0, 1, 2, 20, 16, 17, and 14, 37, and 17. Let's try to display. And let's try to run this command as well. Okay. Coming back to the slide. Now we're going to look at time series analysis. So the origin and goal is to open source Python library and practical real world data analysis, fast, efficient, and easy, and gapless workflow, no switching to some other languages. And in 2008, it was started by Wes McKinney. Now PyData stack at Continuum Analytics of Anaconda, and it's very stable project with regular updates. The main features here are it supports for CSV, Excel, JSON, SQL, SAS, Clipboard, and HDF5. It is used for data cleansing, reshape and merging of data, joins and merge and pivoting, data visualization, well integrated in Jupyter, IPython notebooks, and database like operations of performance. Now first we are going to look at basic functionality of the pandas and a deeper look at the index with the time series index. So we have to import pandas as PD, and then we have to read the CSV file of raw with the data in this temp.csv, and header is none. So we would display the header value. We would display the first 5 values using the head function df.head of 5. Now, input or output of viewing data. The convention is to import pandas as PD and example pd.read underscore CSV. It is very flexible and it has optional parameters which is included of delimiter, header, dtype, pass dates, etc. So you have to preview the data with dot head, number of lines, and dot tail. This is another program from Matplotlib, which we shall be seeing in the upcoming presentation. And so it has implemented this plots in line, which is basically used for data visualization. So this is the plot. using data frame. And so the matplotlib, it is used for data visualization, which is an integrated dot plot, and it is custom and extendable. Plot returns as AX, and it has bar, area, scatter, and box plots, etc. So alternatives to this matplotlib are seedborn and bouquet. So the structure is pd.dataframe and pd.series. As we have seen earlier, data series are one-dimensional label series, and they may contain any data type. The label of this series is usually called index, and index can automatically created if not given. One data type, the data type can be set or transformed dynamically in a Pythonic fashion. Example explicitly set. So this is an example program. We shall implement this. Series equal to pd dot series and np dot random dot rand n. But before that, let's import numpy as np and import pandas as pd. We have to print series. Let's run the selected cell. Let's try to implement this program. Instead of n, let's take random value of integer as 1, 5, and n. Let's run. Let's run now. Okay. has to stop at 10. So we're able to get the value. This format. Now let's head back. Let's try to implement some other programs as well. Instead of 1, 5, 10, we have to take d type is equal to np dot float 64 and index is equal to n into x for x in range of n. Let's try to run this cell. These are the values. So now let's say the index over here is list of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Using the slicing operation over here, up to 110. Let's run the program. All right, so this is the output. Now let's try to perform few other operations. Let's print the series of A and let's print series at 0, then print series at A and D. Have to print the series at 1 and 3 as well. Have to print the series . Series of lambda function x such that x percentile 2. So these are the required output values. Let's head back over here. And this is a graph, axis graph, which is plotted over here. Dot iloc is used to label the index and index position. But dot ix is index guessing label or position fallback. X series dot location of A, that's of C and of B dot plot function. So we have obtained a graph. And let's choose using IX. Let's now use iloc. And the values are 2, 3, 4. Let's run the selected cell. So this is a graph. And for 0, 2, 3, this would be the graph. And okay. Head back to the slide. So here dot sample, it is sampling data set, and dot name, it is used for column of names. Data, pandas as PD, series. Yes, so there's some data and import pandas as PD. And here we have to assign series dot sample of 2. We shall run the selected cell. So this would be Now, selecting data, it can be done by using slicing and Boolean indexing, where series of x and series of x and y, and here's series of 2, 3, series of 2 slicing 3. This can be done by using series.ix, ilog, and location, and series.sample. So data frame, it is a two-dimensional labeled data structure. Of example, data series, story numpy.nd array, and other data frames. Here, index is automatically created if not given. And index, it is automatically created if not given. It can be reset or replaced. And the types are position, time step, time range, and labels. Here, one or more dimensions are involved, and it may contain a value more than once, not unique. And examples are working with series or calculations, creating and adding a new series, how to deal with null NN values, and method calls directly from series or data frames. So this is the df dot columns of timestamp and temperature of df dot head of 3. So let's print df dot columns. Timestamp and temperature. Df dot head of 3. Okay, let's head back over here. So for df up to 100 dot plot, we would get this temperature. And definition to Fahrenheit of Celsius, we should return Celsius into 9 divided by 5 plus 32. I mean, this is a prompt that has to be generated. And we are mapping to Fahrenheit scale up to the values of 5. So there's a program where data frame of temperature, Fahrenheit, we are mapping the scale to Fahrenheit scale. And later we are displaying the head values of 5. So the here head value, by default, it generates first 5 values of a row. And the rule of thumb, And here we have used the describe function. So it generates the mean, the minimum value, and some descriptive statistics. The maximum value, it performs some um, descriptive statistics, which includes mean, maximum, minimum, the STD values. And so coming to modifying series or data frames, methods apply to series or data frames that do not change them, but it will return the result as series or data frames. So with parameter in place, the result can be deployed directly into series or data frames. Series can be removed from DF with drop. So we could do this. And in order to get this kind of graphs, we used matplotlib library, which we would be seeing in upcoming presentation. So this is a timestamp and to describe. So the data aggregation, there are four methods like describe, group by, and unstack, and the mean, sum, median, etc. And here we could display the program, and we would be obtaining the corresponding output. So this D type is of Boolean, and it would return if is null any, it would return the value if there is any null value by using this function is null. And let's head to the next slide. So if df dot drop an a, if data frame a temperature, if it has any null value, then it would return true, else it would return false. And coming to NaN values and replacing NaN, it is actually a representation of null values. And series.describe this particular command, it ignores NaN value. And NaNs, they include remove drop, or replace with default, forward or backward, fill, and interpolate. So the data series and data frame input or output values, and the data analysis and aggregation, indexes, visualization, and interacting with the data. And the next part is to have a deeper look at the index with the time series index. And the period dot to date, it is US date friendly, and data aggregation examples would be seeing this time series index. So df dot index is equal to pd dot to underscore date time df of timestamp. It is to create timestamp index, time series index. So let's try to implement this. Df dot index. PD dot to underscore date and time timestamp. set back over here. And here access is equal to data frame up to 100 dot plot, and this would print in the format of matplotlib. So this we shall be seeing in the upcoming presentation. And here for this particular table, if df.head uh, is is mentioned, and this would display the first 5 values by default, and df.dx index.view would display these values, and df.group by df.index.date.count, it would display this following table. And so all these are examples of matplotlib graphs that we would be seeing in the upcoming presentations. So resample, it is used to display, dot max dot head. This command used to display the maximum value of this particular table with the maximum temperature that's recorded so far at the given timestamps. And by using mean, it displays the average of all the times of the temperatures. The average in August month and the average that has recorded so far in the September month in the year of 2014. And so these are the subplots and which are used in matplotlib. So in pandas, we would do this resampling for hourly frequency, for minutely frequency, secondly frequency, and milliseconds, microseconds, and nanoseconds. And we'll do calendar day frequency, weekly frequency, and month end frequency, quarter end frequency, and year end frequency. Resampling is done in these ways. So now here we would import random, and by performing these operations, we would get this corresponding table of index. First, we have to perform the resample, then we have unsampled. That's the end of the presentation. Thank you.